Hey everybody, welcome to CS302 assignment 5, and for this assignment we're going to implement a Krusty Krab menu. And you can see there that is not a boulder, it's a rock. And of course we know from SpongeBob that the pioneers used to ride those things really just, I guess they use that to deliver the pizza in the episodes. Anyway, so for this program, we're going to be essentially it's going to be a rather simple exercise to just give us some practice using this fancy data structure known as a hash map or dictionary. In C++, it's implemented, or the keyword is unordered map. And for this program, we're going to have an unordered map structure you have to define. And you're going to have a string that maps to a menu type. Now, I believe I spelled menuType incorrectly. It's supposed to be lowercase m, but it's not really a big deal. It's rather simple fix right there. So we're using a map to essentially quickly be able to find different items. So you're going to just have this automated menu system, and the user will want to order various items at the Krusty Krab. And the idea is that we use a map to quickly find this item. So the string is going to be the key, which is going to be essentially the name of the item. And once so if the structure finds this item, it returns that record that contains the item's price, the quantity, and also contains the item's name as well in this object menuType. So let's go ahead and now go over the input file you're going to have to work with. You have to parse this and populate into your unordered map. So this input file that you have to read is going to be in a form of a CSV file. So before I show this, a bright light flash warning coming up, because I don't think you can really make CSV files easily dark themed. So just a warning before I do this. So countdown 3, 2, 1. Kind of hurts actually. Anyway, so you're gonna have to read a CSV file. So remember, for 135, all this really is a comma separated file. So the first line contains item name, comma, price, comma, quantity. That's really what is going to be in the first line. So the first line contains nothing useful, but it's just really there to tell us what each column contains. So really, all you have to do is just use a getLine function to read each line. And then you want to use the find, substring, erase functions to really parse or tokenize this string. Of course, the comma is going to be your delimiter. So unlike in Java or C# where you have that split function, you don't have that in C++, of course. So we have to use find, substring, erase to one by one separate this. But you can assume that every line will contain really 3 values, and we have 2 commas. So you have the name followed by comma, this string that contains 14.99 comma, and then 13. So of course you'd have to use the functions, I believe it's stoi and stod, I believe, to convert from a string to a decimal and string to integer. So of course, not too bad. I mean, this is really the normal way to parse inputs. So in in Java and C#, everything's read as a string, and of course you have functions that can convert a string to a integer or decimal. So we're doing the same kind of idea here in C++. So you don't want to use a string stream library for this. Now, of course, it would work, but the issue is a lot of code that's available online that students might copy often use string streams. So your program could get flagged for possibly having plagiarism. So also, it's not the normal way to really parse or tokenize a string really in the normal way. So I would just say avoid the string stream library. It's also given in a PDF. But the first thing you're gonna have to do is read each line one by one. And then these 3 elements, you're going to have to create a menuType object. And then, of course, each element in your unordered map, the name of the item will be the key. And you're going to insert a menuType record that contains these elements. So you can, of course, use the constructors given to you to populate your map. So let's go ahead and look at the menuType class and just sort of quickly take a look at what each menuType object will contain. So this class will be given to you. So it'll be given to you actually in Canvas, And also on code grade, you don't have to upload this. It'll already be there. So really this is already given to you, and I just will sort of run through this really fast. So for menu type, it contains these three instance variables: the name of the item, the price, and the quantity. And then we have these two constructors. Our default constructor just sets the name to be blank, price and quantity to both be 0. This parameterized constructor just simply sets the name with this n parameter, the price with this p parameter, and quantity with this q parameter. Very straightforward, simple constructor. Then we have our getters, which will just sort of simply get our name, price, and quantity. This void function right here is going to essentially update the quantity. And this one line of code is a very fancy way of just simple. So this is known as the ternary operator. All we're doing is if the amount is less than quantity, then set the quantity equal to 0. Otherwise, set the quantity equal to the quantity minus amount. So it just avoids having if-else's. So it's fancier. Just like, Patrick, pinky out is fancy. This is sort of the equivalent of pinky out, I guess. And then we have this operator right here we're going to be using, because we're going to have to output the menu sorted by quantity. And essentially, we can use a sort function in C++, but then you have to overload this operator for your custom type in order for that sort function to correctly be able to sort from smallest to highest the records by quantity. So each element of the CSV file, you parse that file, and you can just use its constructor to create the object. And you want to insert this object into the map, and you're going to use the name of the item as the key, and then menu type will be the value. So you just insert one by one after reading each line, you tokenize it, create the object, and insert into your map one by one is the idea. And of course, I gave some some instructions here, well, not instructions, but descriptions of what each function is going to do. So let's now go into the contents of main, and I will, of course, will go over this, and as well, I will also do a simulation of the program here on my Linux terminal. So let's go ahead and get to that next. Okay, so essentially the first paragraph is your first phase. As I said before, you want to create an object. I called mine menu, but you can call anything you like. But you want it to be under a map that maps a string to a menu type record. And then, of course, you're going to read in your krustykrab.csv file through a command line argument. So argv1 is going to contain the file name. So you want to pass argv1 into some input file streams open function to open that file so you can start parsing it. So you would just one by one read each line, tokenize it, and then correctly populate your unordered map. And once you have that done, the next phase is you want to output the entire menu. And you want to output it sorted because, well, the idea is that code grade is not very flexible, as you might have already encountered through using code grade for several of your CS classes here at UNLV. And unordered map, the problem is everybody's, so let's say if you're using unordered map, if you're using a Linux compiler or a Mac compiler or Windows compiler, it might store the records in different parts in the map. So we want to use the iterator to traverse the map. You might get different outputs on different environments. Now, of course, it will be the same on code grade, but you want to be able to test it locally yourself. So if, let's say, yours comes out differently, it might not be the best way to test it. So what you want to do is you're going to have to insert all of your menu type objects from your map into a vector. And then you want to sort the vector and then output the name, price, quantity of that sorted vector. And of course, you can use a sort function in C++'s algorithm library to do this, unless you want to revisit the quicksort from a few weeks ago, which I don't think anybody wants to do that. So we'll use the library sort function. So just so you can see that there is in fact a sort function in C++. Now, of course, we spend time during the semester going over how sorts work and why, quicksort is faster than insertion sort and so forth. But now that you already sort of know this, now you've traced out, you've done all of this, it doesn't really hurt to just use the sort function that's sort of given to you in C++. So after that, you're going to have to then prompt the user. And of course, we want to really capture the essence of Squidward in this program, because Squidward, the cashier, is always in a bad mood. So we will have the prompts really just capture the essence of Squidward. So we have, hurry up and order something will be our prompt. And of course, user enters an item that they want to order. If that item does not exist in your map, well, we output to the user, we serve food here. That's again, Squidward, his very pleasant demeanor with the customers. I don't know how the Krusty Krab even has customers. I mean, I think, well, I really think it's because SpongeBob is a great fry cook. That's the reason why people go there for that. But anyway, Squidward, we serve food here. So you have to reprompt. And once you finally enter an item that does exist in your map, then you have to prompt the user, okay, well, how much of this do you want to order? And of course, we will use Squidward's, very pleasant demeanor here, which we'll use Squidward's prompt. You ask them this message. We ask an amount. Now, if the amount that the user is asking for, if let's say there's more, let's say, for example, there's only 5 Krabby Patties and they want to order 10, then they can't make this order. So you tell them, let me see, I can't do the sound effects for this. I think it's like, can we please move this order along? I think I did that pretty well. So you want to, of course, give that prompt message and you ask for the amount. So once the amount is less than or equal to the quantity of this item, we can move along to the next phase, which is going to basically, we're going to accumulate the cost. So you want to keep a running total for the cost of this order. So of course, the quantity of the item, multiply it by the item's price, and we're going to accumulate that to a variable to simply just store that, or we're trying to maintain the order's cost. After that, we're going to then ask the user, will this complete your order? And, of course, Squidward has to do that, of course. And the user can enter N or Y. So if it doesn't complete the order, no. We jump back to the top and we rerun the menu again, and we show the whole entire menu in the Krusty Krab, and the user can select something. If they enter Y, it completes their order, or if there are no more remaining items left in the Krusty Krab. So as orders are being processed, if the order's quantity becomes 0 at some point, we want to remove that item from our map. But again, the map function, there is a function in the unordered map class that can remove a particular item. So of course you want to remove items once their quantities do become 0. So if user enters Y, it will complete their order, or if there's no more remaining items left, you escape this menu loop, and then you just simply output the total along with the actual cost of the total order. So the thing is, I used setW to output everything nicely, but don't worry, you don't have to use setW on your end. I just did that because I wanted to make sure that it looks presentable when I show you the output. And also, you do want to use the set precision too. So you want to output all your decimals to 2 decimal places, but that's a very simple manipulator to use. So setW is a bit more complicated to work with, but don't worry about using setW. I'm not going to have CodeGrade actually check for that. I did it just so it looks nice. So again, for some criteria, please include your header comments. If you have any custom functions in your main which you could use, please document them, and also document sort of, blocks of your code. So for, of course, you always want to have proper documentation of a program, and also always use a map for any searching. Now, of course, when you're going to output everything in your menu, you're going to iterate through the entire menu in your vector. That's fine, but don't actually do any linear searches. Just use your map for inserting, searching, and removing. So we want to use a map because a map is, first of all, it's much faster, and also that map search lookup is going to replace using a for loop to traverse. I mean, maps, of course, for the win. So anyway, the sample output, I have the sample output provided for you on Canvas, but I will go over the sample output shortly. And for submission, only submit the main.cpp. The header file will already be there in the CodeGrade, which will link automatically. So make sure you include the menuType.h in your main file. And of course, when you submit, it will have already the menuType.h already in CodeGrade, and will just link to your program. And also the CSV file will also be there in CodeGrade, so just submit only the main.cpp. So now I want to go ahead and just sort of do a quick trace through of the program so you can see what's going on, and then that'll conclude the video. So let's go ahead and get to that. Okay, so here's my terminal. I put the input file here as a reference for myself so I know what to enter into this program. As you know, in this file, of course, Dr. Kelp and the pizza are the most important items from that one episode from SpongeBob, because not having Dr. Kelp was a big problem, and of course, Squidward took care of that problem in the episode later on. But anyway, you have to watch the episode to know what happens there. So anyway, in my program, I included menuType.age, and of course, you may want to include several libraries. So include unordered map, include vector, include string, include IO manip, include IO stream. You have to include many libraries in this program. So if you have a lot of includes, don't feel strange. That's probably going to happen in this program. So to compile, I would just enter g++ main.cpp. And of course, I included the menuType.age, so it gets linked into this. Now we have our a.out created. So to run this, as always, we do /a.out. And I'm going to pass in the Krusty Krab CSV file on the command line. So I'll type in Krusty Krab. I hit tab to autofill that. So this is going to be stored into argv1, and we're going to use this to open our file stream. Let's go ahead and hit enter. And there's all of our content. So again, I have it nicely, formatted, but again, as long as decimals are 2 decimal places, you're good. You don't have to have it nicely formatted like how I did, but again, it does make it easy to read. So of course, if the first column will be our price, our name, price, and quantity, and notice how it is sorted from smallest quantity to largest quantity, just like that. So again, let's go ahead and order something. Now I'm going to type in diet Dr. Kelp. Now, just a quick, I guess, hint or a quick remark. Sorry. You want to make sure that all of your input is case insensitive. So I could type in different. Let's see over here. I typed in uppercase, lowercase. Just make sure your program does handle it. But so you want to make sure you deal with that. So just a little quick heads up right there. So it's gonna find this item in our map, and how much of stuff do you want? I'll type in 5, hit enter, and we'll complete your order. So I'm going to type in no, it does not complete my order. I'm not a barnacle head either, Squidward. So I'll run this, and then here we are. And notice how earlier our Dr. Kelp, where is it? There it is. We had 20 of them. Now we only have 15 of them. So notice it got resorted. Now it's in the right position. So the idea is we just, read an input just like that. So I can, of course, type in diet Dr. Kelp again. I'll enter 20 this time. Now, we don't have 20 of this item, so it's going to give us this error, that we have some issues there. I'll try, let's say, 17. Again, we have an error. Then I'll try 2. But let me go ahead and actually modify this. I'm going to try 15. So I want to go ahead and buy all of Dr. Kelp's because, well, I guess Dr. Kelp's supposed to be Dr. Pepper in the SpongeBob world, and it is a pretty good soda, actually. So I'm going to get all of these. So I'm going to type in 15 and buy them all. And no, I'm not done my order yet, Squidward. So notice that now we don't have this item showing up in our list anymore. So in my map, since that item's quantity does become 0 after this order, I want to remove it from my map, which of course then it will not be inserted into my vector that I use to sort by quantity and so forth. So anyway, that's kind of how this program would work. Now, in this assignment, we want to, of course, use a Linux redirection in our program. We don't want to be typing all this input every single time into our program. It's annoying. So let me go ahead and just Control-C to end this program. Go ahead and clear and go back to the top. So I'm going to run this once again with Krusty Krab. Now, if I want to sort of feed this input into the program, instead of typing out manually, I want to feed this in automatically from 135. Remember, you can just use this symbol, which is going to redirect it to the input. So this direction is going to be input. So I'm going to go ahead and type in input1.txt. It's going to feed this input into my program. Now, don't ever use this symbol for output. The danger of doing this, you can write it to an output file, but what will happen is if there was, let's say you put like by accident main. I'm not going to put that there. It will wipe out your program and put the output there. So for now, just don't even think about using the output redirection. I just always tell 135 students also just don't use that, because you could accidentally put your source code there and then it gets wiped out. So we'll stick to just input for right now. So it will feed all this into my program. Let's see what happens. So, okay, it worked, but let's look at something. Let's check this out. So hurry up, order something. Well, where's the actual input my program fed in? And it's not there. There's no input actually displayed here on the terminal. And the reason why is because since I didn't actually manually type this input, it's not going to actually show on the console. So to make this, easier to read, and also on CodeGrade to make it easier to see which, let's say for example, you may have some invalid output. It's nice to know which input causes output to happen, so it's easier to parse the output and see what's going on. So for that reason, I'm going to recommend right now what you want to do is you want to output everything you read. So that way it's going to display the actual input right here on the terminal. Let me go ahead to my code quickly. I'm going to just put that code back in. So you want to just, as I said, you want to output everything you read. And I'll show you exactly why you want to do that. So I'm going to go ahead and put those statements back into my program. So I think I should be good now. I think I adjusted everything. So let me go ahead and clear this. Let me recompile. Now let's do Krusty Krab again. Input1.txt. And notice here, check this out. It displays the actual input that was fed into the program. All you have to do is whenever you read anything from cin, either getLine or cin with the extraction operator, just output what you read in. So that way it's going to display this right here on the console, so you know what input was just read in, so you can easily parse the output, so you can see which output, or which input, sorry, caused what output to happen, so it might make it easier to help you see the problem. Also on CodeGrade, it will show you if, let's say, you have an issue, you'll kind of have an idea of which input is what caused that output failure to possibly happen. So now it looks decent. But here's an actual issue if you do see out everything you read in. If I were to, let's say, once again, run this, and this time I'm not going to, I'll just not use a redirection. I'll just type in diet Dr. Kelp. It displays it again because this time I typed it in, and whatever I read in, output right there, which I guess isn't a big issue if you are going to run it manually. You're also going to put macros into your program that you can sort of output for certain cases, but anyway, not a big deal. But just to let you know, you want to output whatever you read in just so it will display it, because even on CodeGrade, whenever CodeGrade reads in inputs, it actually does input redirection also. So you may have noticed in your previous assignments or previous semesters that on your CodeGrade output, it doesn't show the actual input because everything is sort of read in through Linux redirection. So we want to output what it read in, so it just makes it look decent. So anyway, I guess that was a quick simulation of the program. So hopefully this video did explain everything. So I guess happy coding, and till next time.